Hello girls, today we're going to start with lesson 2, the many forms of energy. In this lesson, we'll talk about these objectives. The first objective is to mention types of energy, and then mention types of kinetic energy, mention types of potential energy, and define gravitational potential energy and its equation, as well as study the effect of choosing the reference level on the amount of GPE an object has. Let's start by watching this video.
Without energy, nothing would ever change. Nothing would happen at all.
5, 4, 3, 2, 1. Fire in the hole.
Energy gives objects the capacity to move or change condition. For example, change temperature, change shape, or change state. And whenever anything happens, there is an energy change. Either energy is converted into another form, such as when a generator converts mechanical energy to electrical energy, or energy changes location, like when water in a hot bath warms your body. There are many different types of energy, all of which are measured in joules.
Energy is really the capacity to do work, and you've got heat energy, we've got sound energy, we've got light energy, we've got electrical energy, and the energy, of course, which is most important to us, is heat energy. We need to take energy in the form of various types of food, and we need that to run our body to keep us warm, to make our muscles work.
Without energy from food, it would be impossible for us to function. Energy gives our bodies the capacity to do everything, from breathing to pushing our bodies to the limits.
So, from the video, we saw that just like ice cream, energy comes in different forms. For example, energy can be electrical, or light, or chemical, or mechanical. Now, energy can also transform from one shape to another. So, الطاقة تأتي بأشكال مختلفة، والطاقة تتحول من شكل إلى آخر. For example, in the first picture here, you can see that when you turn on the light bulb, the electric energy is converted into light energy. Also, in plants, the plant takes the sunlight, which is a type of light energy, and converts it into chlorophyll, which is the type of food that plants form. So it turns it into chemical energy. Another example is when you eat food, you turn the chemical energy in the shape of calories in the food into mechanical energy when you move and burn these calories. A very famous example about energy conversions is when a firework explodes. So when a firework explodes, the chemical energy and the heat energy combined will create some light energy as the lights you see in the sky, Also sound energy, which is the light, the heavy boom that you hear. Also, some of it can be converted into heat energy, which is if you are close enough, you will feel the heat coming out of the explosion. أحد أشهر أنواع الطاقة التي سندرسها في هذا الفصل هي الطاقة الحركية kinetic energy. We talked about kinetic energy in the first lesson, and we learned how to calculate the kinetic energy using its equation, KE equals half mass velocity squared. In this lesson, we'll talk about the types of the kinetic energy. The first type of the kinetic energy is the translational kinetic energy. And translational stands for when the object changes position. So if the object moves from one position to another position, then we can say that this object has translational kinetic energy. And we can calculate it using the equation we have learned in the first lesson. KE, which stands for kinetic energy in joules, equals to half mass in kilograms multiplied by the velocity of the object squared, where the velocity is measured in meters per second. Another type of kinetic energy is the rotational kinetic energy, and it's the kinetic energy of a spinning object. So it's an object that's not moving from one place to another, like in the first example, but an object that rotates around its axis. For example, the ceiling fan, or a steering wheel, or a tire. All of these are rotating around their axis. Any object that's spinning around its axis is called to have a rotational kinetic energy. We can calculate the rotational kinetic energy using this equation. KE rotational, which stands for the rotational kinetic energy, equals to half multiplied by I multiplied by omega squared, where I is the inertia measured in kilograms meters squared. So it is similar to the mass in the above equation. And omega here, this omega is the angular velocity. So it is similar to the velocity in the first equation, and it's measured in rad per second, or degrees per second. What you have to do is to memorize this equation and memorize each symbol and what it means. Here, this is an example of an object that has both a translational kinetic energy and rotational kinetic energy. When this person stands on the board and she pushes herself downwards, the diving board will push her upwards, doing work on the diver. Now this diver starts to go up into the sky and starts to rotate, hence it has rotational kinetic energy, and at the same time you can see that it moved a distance, it moved from one place to another, so it also has translational kinetic energy. After that, she stops rotating and then starts to free fall all the way down to the water, in which, in this case, she will have only translational kinetic energy because she stopped rotating around herself. In this question, when a car wheel rolls down over a hill, which of the following statements is true? Now you can see that when a wheel or a tire starts to roll down a hill, it has two types of motions. First, it's moving from one place to another, and hence it has translational kinetic energy. And at the same time, it's rotating around its axis. Hence, it has rotational kinetic energy. So, the correct answer is it has both rotational and translational kinetic energy. Which of the following equations is used to calculate the rotational kinetic energy? That's the first equation, half times I times omega squared. Now, let's talk about potential energy and its types, and we'll also talk about how to calculate the gravitational potential energy and see what are the factors that it depends on. Let's watch this video first.
The ability to store energy is a vital requirement for life on Earth. From plants storing the energy they receive from the sun, to animals storing energy they gain from food. The fossil fuels we use every day are the remains of deceased plants and animals. Energy converted from the sun and stored for millions of years, released to meet our modern energy needs. Potential energy is energy that is stored in one form, which can be transferred into a useful form at a later point in time. And there are various forms that potential energy can take. Chemical energy is the potential energy stored in molecular bonds. It is released through chemical reactions. Batteries, for example, store chemicals which can produce electrical energy on demand. When materials are deformed, either compressed or stretched, energy is stored as elastic potential energy. Materials resist being pulled, so energy is needed to stretch them. When they return to their original shape, it is released as kinetic energy, or movement. When an object is raised to a height, it is given the potential to gain kinetic energy when it is dropped. Dams work on this principle. The water behind the dam is much higher than the water in front. When the water drops through a turbine, the kinetic energy released from the potential powers generators. Chemical, elastic potential, and gravitational potential are just some of the forms in which energy can be stored, giving us the ability to choose when energy is released.
So just like you saw in the video, potential energy is the energy stored in an object. So for example, if you take a bow and an arrow and you pull the arrow backwards, you store energy in it. And then when you let go of the arrow, this energy stored in the arrow will start to convert into kinetic energy. So here, the energy conversions are from stored energy, which is potential energy, into kinetic energy when you let go of the arrow. Also, you know that potential is a common word that we use every day to tell anyone if they can do much in the future. So, for example, if someone says to you that you have so much potential, that means that you're bright and you can do a lot of things. You have so much stored energy and talent in you. So, potential energy is the energy stored in an object. Now, the symbol of potential energy is PE. Just like kinetic energy has a symbol KE, potential energy has a symbol PE. And both of them are measured in joules since both of them are types of energy. Now, there are two types of potential energy. You have elastic potential energy. Elastic potential energy is the energy stored in stretched or compressed materials. So, for example, if you compress a spring, just like in this toy here, you store elastic potential energy. طاقة مخزنة مرونية. Also, the same thing when you stretch a rubber band. When you stretch a rubber band, you store elastic potential energy in it. Similarly with the trampoline is made out of rubber, so it would be easier to stretch and compress. When you jump up and down on a trampoline, you stretch it, you're storing elastic potential energy in it. Here you can see that we have a lot of elastic potential energy accumulated with these rubber bands on the watermelon that caused at the end for the watermelon to burst. Another famous example of elastic potential energy is the bow and arrow that we discussed earlier. As a ministry question, it says, which of the following examples shows elastic potential energy? A river flowing down a hill, the battery of a flashlight, a golf ball at the edge of the hole, or energy stored in a bow and arrow. Just like you saw earlier, the last one is an example of elastic potential energy. When you stretch this this string at the back using the arrow, you store elastic potential energy in it. And this elastic potential energy converts into kinetic energy once you let go of the arrow. Now, the other type of potential energy is called the gravitational potential energy, طاقة المخزنة الجاذبية, and we symbolize it with GPE, which is the beginning letter of each word, gravitational potential energy. And because it's an energy, it's also measured in joules. Now, gravitational potential energy is the energy stored in an object due to gravity. When you lift an object up the ground, higher and higher, you store gravitational potential energy in it. The higher you lift it upwards, the more energy you store in it. We can calculate the gravitational potential energy by using this equation. The gravitational potential energy stored in an object lifted above the ground is equal to the mass in kilograms multiplied by g, which is the gravitational field, and on Earth it is equal to 9.8 newtons per kilogram, multiplied by h, which is the height from the reference level. That makes the equation GPE equals mgh. Now be careful about the reference level. Reference level is the point or the surface you measure your heights from. And it can differ from one situation to another. So for example, I can measure the height of a light bulb from the surface of the ground. Another person can measure the height of the light bulb on the ceiling from, for example, the table as the reference level. If you change the reference level that you measure the height from, the amount of the gravitational potential energy will change as well, because as you can see, it depends on the height, which can be measured according to a reference level. And we will see an example at the end of the video. So, what does the gravitational potential energy stored in the object depends on? According to the equation mgh, you can see that the gravitational potential energy depends on two factors, or three factors, but as long as we are on Earth, it's just two factors. The first factor is the mass. You can see the bigger the mass, the more gravitational potential energy the object stores. So, the gravitational potential energy stored in a piano would be much higher than the gravitational potential energy stored in a watermelon if they are pulled at the same height. That's because the piano has a bigger mass. So, if the piano falls on this person, he will definitely die because this piano holds a lot of stored energy, and this stored energy will convert it into kinetic energy. And this kinetic energy, this big amount of kinetic energy, will crush this person. While here, in the watermelon, because it has a small mass, it will have a smaller amount of energy stored in it. And this stored energy, the small amount, will turn into a small amount of kinetic energy, which will not harm this person, not as much as the first person anyways. What's the other factor that the gravitational potential energy depends on? Now you can see according to the equation, it also depends on the height you lift the object from. And as the height increases, the gravitational potential energy stored in the object increases as well. So, for example, if you were to hold a watermelon at a very small height, and then drop it, nothing will happen to the watermelon. Because you lift it a little bit above the ground, it stored a little bit of gravitational potential energy, in which turned into a little bit of kinetic energy when you let go of it. But on the other hand, if you take this watermelon and lift it above a building and then let it go, when it hits the ground, it will be crushed. Why? Because when you lift it above the ground at a very high or like at a high heights, say, or a very big distance from the ground, this watermelon will store a lot of gravitational potential energy in it. And this massive amount of gravitational potential energy stored in the watermelon will be converted into kinetic energy, which is a massive amount of kinetic energy when it reaches the ground. Hence, because it has a lot of kinetic energy, it will hit the ground at a high speed, which will cause it to explode. So again, the height at which we lift the object affects the gravitational potential energy. The higher the object, the more energy is stored in the object. Let's see this question. A pole vaulter of a mass 52 kilograms. So given here is the mass of this pole vaulter. We're going to symbolize it with M. Jumps to a height of 6.12 meters. So that's the height, H. And you can see that the height is measured from the ground. So the ground here is the reference level. To clear a bar as shown in the figure, what is the gravitational potential energy stored in the pole vaulter at that height? So he wants you to find how much energy was stored in this person when he jumped or when he reached that height. So GPE is equal to mgh. Multiplying the mass, you can see all of the quantities are in their right units. So the mass is 52. And remember, G is a constant value of 9.8. G is always 9.8 on the ground, unless it's mentioned otherwise, which you will use the new value given to you in the exam, times the height, which is 6.12. Now using the calculator, 52 times 9.8 times 6.12 will give you 3,118.7 joules of energy, which is the first answer right here. Okay, now let's talk about the reference level, اللي هو بالعربي مستوى المرجع. The amount and sign of the gravitational potential energy depends on the chosen reference level. تعتمد قيمة وإشارة الطاقة الجاذبية المخزنة في الجسم على المستوى المرجعي الذي تم اختياره. فمثلا خلينا نفترض إنه عندنا هون بطيخة موضوعة على سطح الأرض. هاي البطيخة موجودة بجانب شخص، هذا الشخص باللون الأزرق. هنا في عندي شخص باللون الأصفر يقف على شرفة أحد الشقق، وعندنا شخص باللون الزهري يقع في حفرة تحت مستوى الأرض. فلنفترض إنه بدنا نوجد كمية الطاقة المخزنة الجاذبية التي تمتلكها هذه البطيخة بالنسبة إلى 3 مستويات مرجعية. فلنبتدئ في المستوى المرجعي اللي هو الأرض. خلينا نفترض إنه إحنا اخترنا المستوى المرجعي. We chose the reference level to be the surface of the ground. So we're going to measure the distances and the heights from the surface of the ground. Now, this watermelon, هاي البطيخة موضوعة على المستوى المرجعي. هذه البطيخة, this watermelon, is placed on the reference level. So how far away is it from the surface of the ground? Well, because it's placed on the ground and we're measuring the heights from the ground, the height here is 0. It's not lifted, nor it's below the reference level. Hence, if the reference level is chosen to be the ground, the melon is at a height of 0 meter from the ground, and hence, if you want to calculate the gravitational potential energy, multiplying the mass of the watermelon times 9.8 times h, which is 0, will give you a gravitational potential energy of 0. But now let's imagine we're going to measure the gravitational potential energy of the same watermelon, but from a different reference level. Now we're going to choose the reference level to be the balcony. So we're going to measure the heights and depths from the balcony. So here the balcony is the reference level at which the height is 0 and the gravitational potential energy of anything placed on the balcony would be 0 as well. So the gravitational potential energy stored in this person according to this reference level is 0 as well because he's on the reference level. But how much is the gravitational potential energy of this watermelon if you chose this reference level? You can see now that the watermelon is below the reference level. You can see that is, for example, 7 meters below. So if the reference level is the balcony, the melon is 7 meters below. So it will have a negative gravitational potential energy. If you calculate it, you'll multiply the mass of the watermelon times 9.8 times h, which will be negative 7. So the gravitational potential energy of the same watermelon would be a negative value, like for example, negative 35 or negative 40 joules. Even though it's the same watermelon, just because we changed the reference level, the amount of the gravitational potential energy stored in this watermelon changed as well. But now let's choose the hole as the reference level. So we are measuring the heights from the hole. Now you can see if the reference level is the hole, the melon is 5 meters above the reference level, and hence it will have positive GPE. So if we want to calculate the gravitational potential energy of the same watermelon, you'll multiply its mass times 9.8 times h. In this case, it will be positive 5. So it will give you a positive value for GPE. So you can see that changing the reference level changes the amount of the gravitational potential energy stored in the object, even if it's the same object. So here it was 0, here it was negative, and here it was positive. Let's solve an example on that. We're going to delete everything here and solve again. But this question says we have an 0.5 kilogram vase, so that's the mass of the vase. And this vase is placed on a table in the following image. You can see the vase is on the desk here. Find the amount of the gravitational potential energy stored in the vase at the following. Find the amount of gravitational potential energy it has according to the following reference levels. The first reference level chosen is to be the ground. So here we're measuring the heights and depths from the ground. In this case, you can see that this vase is 1.5 meters above the ground. Hence, to find the gravitational potential energy in the vase, we will multiply mg times h. Its mass is 0.5, and g is a constant value, always, دائما, 9.8, unless mentioned otherwise in the question, times h. Now, because we chose the ground as the reference level, you can see that this vase is 1.5 meters above the reference level, so it's 1.5 positive. Using the calculator, if you multiply 0.5 times 9.8 times 1.5, gives you a syntax error. 9.8 times 9.8. That gives you 7.35. But now, in the second branch, you want to find the amount of the gravitational potential energy stored in the vase, but we're going to choose the desk as the surface level or the reference level. So now we're measuring the height from the desk. Now, because this vase is placed on the desk, it's not lifted above it, so it's at the height 0 from the desk. That means if you multiply mgh, it's the same as 9.84 g. But because the vase is placed on the desk, it's at a 0 meters height from the desk. So that will give it as 0 joules of energy. Lastly, he wants us to find the gravitational potential energy stored in the vase if we measure our heights and depths from the ceiling. So we're measuring the heights and depths from the ceiling. Similarly, GPE equals mgh. The mass is 0.5 and g is 9.8. But for the height, you can see that the vase is 2 meters below the reference level. So below, since it's below, we're going to put negative. Remember, anything above the 0 is going to be positive. Anything below the 0 is going to be negative. So since it's below the reference level, it's going to have a negative value, minus 2. So multiplying this using the calculator, 0.5 times 9.8 times negative 2 will give you minus 9.8, of course. So you can see that changing the reference level from which we measure the heights and the depths changes the amount of the gravitational potential energy stored in the same object.